3.159. Okay, 10 times 3.14159. So you see that the last value is 10 times 3.159. 31.4159. Okay, and the interval between each value is 50 over pi. What is 50 over pi? 3.4159, okay, divided by 50. Okay, so let's say I want to say Z. Okay, so you see here, the interval here is 0.0628. So every year is increased by 0.0628. Okay, so now, now you see here, okay, we plot sine t for sine t. So this sine t here is my x. Okay, you can add more. X is equal to sine t. Okay, y is equal to cosine t. Okay, and z is equal to t. Okay, so now you put here plot x, y, and z. Okay, so if you look at this, okay, when you put semicolon because I don't want it to be, okay, so sine t, for sine t, z is equal to t. Okay, so you will produce this helix. Okay, this helix. Okay, so t here, sorry, z, this one is x, y, and z. Okay, x, y, and z. Okay, so let's look at, we already know what is the, we already know what is our t value. Okay, what our is t value. So t value is here. This is our z. Okay, this is our z. Okay, so it is from 0 pi, from 0 until, okay, 10 pi. What is 10 pi? 31.142. Okay, here, this is our z value, which is our t. Okay, so x is sine t. Okay, x is sine t. So double click here. So you see here. Okay, x is 0.0 sine t is 0. 0. Next is 0.062. And the last one value is, okay, here 0.0000 and all that. Okay, so this is sine t. And if you cosine t, okay, so it starts with 1. Okay, then ending also with 1. Okay, ending also start with 1, ending also with 1. Okay. Okay, so here, okay, I can produce this helix value. Okay, helix value. Okay, so this is a simple example of a 3D but plot on a 2D projection. Okay, this one I didn't put any title, I didn't put any label. Okay, but you also have to put it. Okay, how is it? Okay, you see here, this graph here is this graph here. I have the equal matrix. Okay, I have equal matrix. So how do I know? So you see here, my x, y, z all have one row and 501 column. Y also one row, 501 column. Z also one row, 501 column. So which means that, okay, we have to, for a 3D graph, okay, we have to have a same dimension so that it can plot correctly. Okay, it can plot correctly. Okay. Okay, so now we're going to, okay, we have to go for the next. Okay, so now we have a more complex value, a more complex code, a more complex plot. Okay, more complex plot. This one is only the simple helix, right? So what if I want you to customize the color and also the marker? Okay, so what if I want to customize the color and also the marker? Okay, so okay, I give to you in Teams. Okay, so this one is to customize color and marker. Okay, okay, so here, okay, again, it's the same thing. Okay, I create value of t, okay, which is equal to 0 until 10 pi. Okay, I create t as 0 until 10 pi, but my interval is only pi over 20. Before this, we use pi over 50. Okay, so I put xt, which is sine t, yt is cosine t. Okay, same like the previous one. Okay, now, okay, I use a plot 3D, plot 3, yxt, yt, t. So which is x, y, z. This is xt is x, yt is y, t is z. Okay, here, I want it to be in dash. Okay, O. Okay, so which means that, okay, color is in blue. Okay, so this is the marker that I want to do. It is circle. Okay, marker is circle. So size 10, and the marker face color here, it is a slightly red, sorry, no red, sorry, pastel blue. Okay, here I use the RGB code. Okay, this one is I use RGB code. So every point here, okay, is okay in this color. Okay, so you can also change it. Let's say you want is circle, and you want to change it into a magenta. And okay, okay, so this one is only marker. Okay, it's only marker. Okay, the line, outer line of the marker is blue color. Okay, and the size is 10. Okay, let's say now marker I think is a bit bigger, so I want to customize it. So again, I want the line to be there. Blue color marker size I want to put as 5. So yeah, we just have to write. Okay, so for helix, okay, we use sine and cosine and also the value of pi for the z coordinate. Okay, so okay, this is like example of helix. Okay, this is example of helix. So let's say I don't want this line, I don't want this line, so I want to customize it to use a different line. Okay, I will copy my code and I will put in Teams. Do you get this plot? You get this plot? Okay, wait, okay. Okay, now here I want it in different line style. Okay, I want in different lines. Star. Okay, here is 0, so until 10 pi. Okay, so here I have xt1, which is sine t, yt1 is cosine t. Now, okay, xt2 sine 2t. So this one, you see, we have two conditions, two situations here. So which means that we have two helix. Okay, we have two helix. The first one is sine t cosine t. The second helix will be sine 2 times t cosine 2 times t. Then we plot, okay, or the first helix yt1, yt is xt1, yt2, xt2, yt2, and okay, so this one xy, xy, and our z value is only t. Okay, our z value is only t. Then we use dash dash. Okay, this one I did not specify the color of the line. Okay, I did not specify the color of the line. So we use whatever MATLAB decide for me, which is blue and red. Okay, so here is xt1, yt1. Sorry, this one xt, but we have two here. The blue one is sine t cosine t, and the red dash line here, okay, the red dash line here is sine 2t cosine 2t. Okay, the red dash line is sine 2t cosine 2t. Line is sine t cosine t plot. Okay, and here it is t value. Okay, this is when you want to specify it. Okay, let's say you don't want to do any specification to the line. So it will be by default, it's only red and blue like this. Okay, only red and blue like this. Okay, but now, okay, let's say I put this as, okay, you can add marker also. Okay, you got this plot? Everyone okay? Okay. So what if you don't know? Okay, how to helix? You do have any idea how to get this? It's like you're not very well with the mathematical foundation. Okay, don't worry. If you want to produce something like this, usually there's an equation to help you. Okay, because this course for you is only to produce output, not to learn mathematics. But you have to have a bit of mathematics knowledge. Okay? Okay. Okay. Now, okay. Okay, we have plot multiple line. Okay, we have plot multiple line. Okay, so I'm going to do again in Teams. Okay, I put it in Teams. Okay, this one also the same. Okay, but I just want to show you how it is done. Okay, so this is a plot multiple line. Okay, this one we go more. Okay, this one is we do t is 0 until pi, but the interval is 0. Sorry, the interval is pi over 500, so the value is is smaller. From 0 to 3.142, okay, this we put an interval value which is pi over 500. Okay, so some of my students ask me, Miss, why for the 3D, most of it we use this type, we use column. Okay, we don't use linspace. Okay, you also can use linspace, but for pi value, it's easier for us to use this type of format. Okay, then xt1 is sine t times cosine 10t. Yt1 is sine t times sine 10t, and zt1 is cosine t. Okay, so you see here, zt, okay, and next is sine t times cosine 12t, and yt2 is sine t times sine 12t, and zt is the same like the previous one, which is cosine t. Then we plot it. Okay, this one we not specify our line, okay, but we only specify we only have two lines. Okay, you will get sphere helix, okay, but it's more, it's looking like sphere. Okay, helix is looking like sphere. Okay, you can also put grid on if you want to see more. Grid on. Okay. Okay, so this is sine t cosine t. Sorry, sine t cosine 10t for the blue color. Okay, and for the second one, sine t cosine 12t, sine t times sine 12t is the red line. Okay, again, you see here, all the value created are in the same dimension. Okay, it is in the same dimension, one column, one row, 501 column. So one row, 501 column. Okay, is in the same dimension. Okay, so before this, we only deal with when our value has one row and many columns. Okay, what if we have a matrix of data, m by n matrix, okay, and we have many plots. So which means that we will have a more defined 3D surface graph. Okay, if the argument to plot 3 are matrices of the same size. So let's say I have 501 matrix by times 501 matrix. So which means that I will have a 501 matrix times 501 matrix for X, 501 matrix row, and also column 501 for Y, and also for Z. It has to be the same size. Okay, so we use the new function, we call it as mesh grid. Okay, we have a new function, we call it as mesh grid. Okay, so you see here, I create a mesh grid from -2 until 2, and the increment is 0.1, okay, for X and Y. Okay, so I create a square matrix of X. Okay, I create a square matrix for Y, okay, which has the value of -2 until 2, and the increment is 0.1. For Z, okay, because it generated from X and Y, it will have also the same dimension. Okay, we have the same dimension. Okay, but Z is equal to X times exponent negative X squared minus Y squared. Then we plot. Can you copy this code and put it in your uh, MATLAB? Okay, so you see here, close first. Okay, so you see here, I have a 41 times 41 matrix, 41 row, 41 column. Okay, mesh grid means, okay, you create a square matrix from -2. So you see here, the first value is -2, second row -2, and it increased by 0.1. Okay, and it will end at value of 2. Okay, so you see here, we also have a 41 value. Okay, same for x, the same. And for z, because we have equation for it, which is exponent x times exponent x negative x squared, exponent negative x squared minus y squared. So this is the value. Okay, so when we plot it, okay, so you will get, okay, when you plot it, okay, you will get like this. Okay, so in MATLAB, because the software is very powerful, you can use your uh, mouse, your cursor, okay, to spin around to see different angle. Okay, you see here. Okay, you can spin around using your cursor to see different angle. Okay, so here is like flat. Okay, then you can see here, and you can spin around to see how it looks like from different angle. Okay, so you can spin it around to see from different angle. Okay, do you get like this? Okay, so you know, if you notice here, all x value, t value here, okay, I did not specify the color, so it all follows, okay, it all follows whatever MATLAB decide for me. So yeah, this color, okay, so it all follows what MATLAB decide for me. Okay, so next is, okay, I want to show you another one, okay, which is they plot multiple line also using metric, but this one will not use mesh grid. Okay, this one I do it manually without using mesh grid. Okay, I copy it and put in Teams. Okay, so here, okay, I do using matrix, okay, using multiple line using matrix, but this one I'm not using mesh grid, but I use independent variable and upgrade my own. Okay, so here you see is 0 until pi. Okay, so x1 on the first row, it is sine t times cosine 10t. Okay, so x on the second row, okay, it will be sine t cosine 20, and x3 on the third row is this. Okay, again, same for y, and z is cosine t. Then I plot x, y, and z. Okay, and this one for x, okay, for x we have 501 value. For y we have 501 value, and for z we also have 501 value. Okay, this one I'm not using mesh grid, but okay, I create my own. Okay, so you see that X we have 3 row, Y we also have 3 row. This one I'm not using mesh grid because mesh grid will create a square matrix. Okay, and this one we only have 3 row. Okay, we have only have 3 row. Okay, so okay, um, okay. Next is okay. I use mesh grid okay to create my first 3D surface graph. Okay, here I will demonstrate how to put a title, how to put the x-axis, y-axis. Okay, because it is 3D, we also have z-axis, so we call it as z label. Okay, we call it as a z label. Okay, and here we use the function of cell. Okay, here we use the function of cell. Okay, I'm going to copy this and put in this. Okay, so first of all, I create a mesh grid, which is a square matrix from -3 to -3 until 51 xx. Okay, -3. This one is clean space. Sorry, clean space from -3 until 3, which has 51 value. Okay, but this one we don't have use pi, so we don't use the semicolon, we use clean space. Okay, so that's why here you can see that my xx and yy, okay, my xx and yy, okay, we will have a 51 by 51 matrix. Okay, and z is, okay, xx times exponent negative x squared minus y squared. Okay, and c is, okay, xx time. Okay, so this is actually the color index. Okay, this is actually the color index. Okay, you can also, okay, please uncomment this first. So please comment the C first. Okay, we don't want to put the color. Okay, we just want to see it without any color specification. Okay, figure, open the figure window, sub. Okay, sub means, okay, it is a function, okay, to another function, okay, when we specify the color here. Okay, when we specify, sorry, we have to uncomment this. No, then we cannot use sub. Okay, we put title, X label, Y label, Z label. Okay, you will see the graph like this. Okay, you will see the graph like this. Okay, so this one is the color, okay, that we use, XX times YY. Okay, so now please uncomment axis type and color bar. Okay, you will see a color bar appear, okay, on the right side. So this is your color bar. Okay, let's say this one is sometimes in geography or like in meteorological graph, they like to see color like this. Okay, so say this one is maybe like you want to know what is the range. So it is between 8 until 6, like that. 8 until 6. So from this corner, it is a blue, right? So it is between 8 until 6, the value. Okay, so let's say if I want to find, like maybe this is like the rain distribution in Kuala Lumpur. Rain distribution in Kuala Lumpur. So I will see that, okay, from this date, okay, this color. So which means that the rain is falling, the rain distribution is quite high during that time, something like that. Okay, so we use color bar here, okay, if we need it, but if you don't need it, just don't put it. Okay, so this is my first 3D graph, okay, by using mesh grid. Okay, by using mesh grid. Okay, so you see here, x-axis is here from -3 until 3, y-axis is from -3 until 3, z-axis we have equation for this, which is x times exponent negative x squared minus y squared. Okay, and the color index here is 1. Okay, before after this, we're going to explore more about the color index. Okay, so we're going more. Okay, MATLAB defines a surface by the z coordinates of point above a rectangular grid in the xy plane. Okay, so which means that the z coordinates is the point above the xy plane. So the plot is formed by joining adjacent points with straight line. Okay, surface plots are useful for visualizing metrics. Okay, that are too large to display in numerical form and for graphing function of two variables. So that's why we create another z. We have x and y, which is equal value, and z is following the equation. Okay, so MATLAB can create different forms of the surface plot. Usually we use mesh plot, which is wire-frame surface that color only the lines connecting the defining point. Okay, so if you notice it earlier, when we use mesh grid, okay, use mesh grid here. Okay, when we use mesh grid here, okay, it connect the line, okay, between x, y, and z value. Okay, it connect the line between x, y, and z value. Okay, and subplot displays both the connecting lines and the faces of the surface in color. Okay, so when we use surf, okay, this one is only plot 3. Okay, but when we use surf, this function, okay, so it display connecting line and faces of the surface. Okay, and also face of the color of the surface. Okay, but if you use plot 3, it's only connecting line of x, y, and z. But if you use this function, surf, okay, it connect line and also the color of the surface. So that's why you have to use C here with the color index. Okay, so you see here when you use surf, okay, every connecting line it has color. Okay, every connecting line it has its own color. Okay, so we also have here mesh C, surf C, mesh Z, and surf L. Okay, you can try by your own. Okay, so this one is the how to the various form get to represent metric as a surface. Okay, mesh and surf is the graph function surface z is equal to f x y using the color specified in C. Okay, but if let's say you don't want the C, okay, you can also ignore it. Okay, you can also ignore it. Okay, so let's say you don't want any C here. Okay, you just want you want to set the MATLAB to specify for you. Okay, this is what MATLAB automatically decide for you, the color of the surface. Okay, the color of the surface. Okay, because I didn't, it's by default, I just use whatever MATLAB decide for me. Okay, this is with the, for the color surface. Okay, after this we will see if it's rainbow, if it's so many different colors. Okay, mesh C and sub C is the graph of surface but projected onto XY plane. Okay, so now let's try sub C. Okay, let's try sub C. Okay, then okay, this one is the put and emphasize on iso line. What is iso line? Here, bottom here. Okay, we have iso line. Okay, in oceanography, in science, okay, in meteorological, in geographical, they want to know, okay, the iso line. This is mesh C. Do you get this plot? You can omit the C if you want, then just let the MATLAB decide for you. Okay, so this is mesh C. Mesh C. Okay, so let's say I want to use and so sorry, sub C is what I use. Okay, now let's try if I use mesh C. I try mesh first. Okay, so for mesh, okay, it color the line, but not the surface. Okay, it color the line, okay, but not, it colored only the line, but not the surface. Okay, now if you use mesh C, it would be similar like this, but with the iso line at the peak. Okay, so if you put mesh C, okay, you will get a graph like this, which have the iso line, okay, by using the mesh function. You get it? This course is very nice and it's very interesting, right? To learn how to plot many types of graph. Okay. Okay, I know you said that it's difficult. No, it's not difficult actually, because it's open book. So you just have to think how to gather the information into the body. That's all. Okay. Okay, we have done surf mesh C. Okay, let's try mesh Z. What's that? Mesh Z and surf L. Okay, let's try mesh Z. Okay, mesh Z is graph with a certain around the parameter of the grid that drops. Okay, that drops the bottom of the z-axis, giving the impression of a drag tablecloth. Okay, it's like, you know, tablecloth. Okay, so from the z value here, it dropped down to the y and x-axis. Okay, so this is messy. Okay, can you try surf L, please? I walk around and check your PC. Okay, for sub okay, for sub L, drop the C. Okay, for sub L, drop the C. Okay, sub L is actually the graph. Okay, making drawing with shading. Okay, from a light source. Okay, from a light source. So which means that okay, we assume that the shading here we cannot specify it. For sub L, the MATLAB will specify it. Okay, so it depends on the source. So maybe this one is pointed here on the peak. Okay, so it follows the value on the peak and color automatically by itself. 5 minutes. Okay, I give you 5 minutes break, then we begin 9:10 minutes. Okay, they say now say you can doing so. Thank you. Hey, Swan, the endings we have to do it, right?
I have to do
The marker.
all need marker.
Ah,
Oh,
you have to do marker. It's like professional graph, you need marker. Simple and yeah, a row and also axis.
like
Axis origin.
we have to change origin also.
Mm-hmm.
Oh, so basically, actually, I did the code for that one, but I'm just not sure if I hit. So if I uncomment this part, it will become like this. Change the axis
Put
origin.
Put two
Put here, right,
outside.
outside. Okay.
I think because it's two. But put marker. This marker. Can I look at the question again?
This one, this question didn't specify.
Then put marker. According to this. This one should be color, right? This one color. The circle color. This one without empty. Empty.
Okay.
Okay. But axis, plot dash line as a center. Okay, already do.
That one already.
Don't put outside. It's very too much, right? This one, that. Put layer. Layer top. You can put layer top. Or maybe this one, you put this first. Yeah, maybe put layer top. Try to find it.
Layer 0, right? And also I the layer top from 0. So
Okay. Okay, so we're going to continue. Okay, but the most popular for 3D surface plotting in MATLAB is mesh and also surf. Okay, is mesh and surf. Okay, mesh and surf commands create 3D surface plot of a matrix data. It create like a wireframe view of the surface and display it in a 3D view. Okay, so that's why there's no color on the surface, it's just a color wireframe. Okay, if Z is a matrix for which the element Zij define the height of a surface over an underlying XY grid. Okay, so Z is actually the height of a surface. Next is if you use surf plot. Okay, surf plot is generate a color faceted view of the surface and display it in a 3D. Okay, so usually the faces are quadrilateral, okay, in which each of which is a constant color outline. We have a black mesh line. But the shading command allows you to eliminate the mesh line. Okay, we use a shading flag or to select interpolated shading across the faces, which uses shading shading interpolation. Previously, we used C, right? So the C is actually the shading interpolation. Okay, we're going to explore more after this. Surface object properties provide additional color, additional control over the visual appearance of the surface. Okay, you can specify edge, line style, the vertex marker, face coloring, lighting characteristic, and so on. Okay, now I'm going to explain more about SERP. Okay, I'm going to explain more about SERP. Okay, so how to change the face, how to change. Okay, I will explain a bit of here what you learn in SERP, but not all. Okay, you can serve by your own. Okay, so now, okay, we're going to use a SERP graph. Okay, I put it in Teams. Okay, all the SERP graph. Okay, so this is all the SERP graph code. Okay, I have comment all that. Okay, so we're going to do first line by line. Okay, now we're going to create a mesh grid. Okay, we are going to create a mesh grid, which is a square matrix. Okay, which is a square matrix. Okay, from 1. Okay, from 1 until 10. Okay, for X, and it increased 0.5. For Y is 1 until 20 and increase by 1. Okay, so you run it. Okay, so you see here, X is 20 times 90 graph, and actually 20 times 90. So this is, it increases every 0.5 from 1 until 10. Okay, so also the same for the row. It's only one, sorry. Only one. The row is 1, 1, 1. It's the same. Okay, square matrix. Okay, and Y also the same. Okay, and Y is, Y is 1 until 20. Okay, this is for Y. Y until 20. Okay, for every row. 1, 1, 1, 1, 2, 2, 2, 2, until the last one, it is 20. Okay, and this one, the increment is not stated. So by default, it use 1. So 15, 16, 17 is not 15.5, 16.5, and so on. Okay. Then Z is sine Y, cosine Y. Then we use SERP. Okay, so this one, okay, when you run it, okay, you get this. Okay, this graph. Okay, so now this one I did not specify the color. Okay, let's see if I want to specify the color, and I put the color bar. Okay, and I put the color bar on the right side. Okay, so here C is, I put as X times Y. Okay, this is the color grading. So you see here, okay, so it looks like this. Okay, so you can turn around to see how it looks like from different angle. Okay, how it looks like from different angle. This is when you want to specify the color. Okay, what if you don't want to specify the color, but you want it to be on true color according to the MATLAB? Okay, you want to specify it according to the MATLAB. Okay, so here you see we create the value of x, y, and z. Okay, you create the value of x, y, and z. We use Pix25. Then you plot. Okay, so the first color, okay, for z, when z is equal to 1, is red. Okay, and green on the second for the value of z. And last one is sum x, y, z. Okay, this one is more advanced. Okay, we use Pix25. Okay, this one you don't need to know, but I just want to show to you. Okay, actually we don't use Pix25. Okay, it's like this. Okay, now if let's say you want to modify the surface plot. Okay, you want to modify the surface plot to make it a bit transparent. To make it a bit transparent. Okay, please uncomment this. Okay, so you see it's a bit of transparent. Okay, same like in 2D graph, you use phase alpha. Okay, we put 0. So a bit transparent because I use 0.5. If it is a solid color, it will be 1. Okay, so you see here all the plot here, okay, is created and you still can see what is on the back. If there any peak or is there any curve. Okay, now this one, we have a black color that connect to each other. Okay, you see it's like mesh. It's like mesh and also the surface is color. Okay, what if I don't want all the black line here, all the mesh line here. So I use S as the edge color, then I put it as none. So you see here, there's no line. There's no line for the 3D surface using surf function. Okay, there's no line. Okay. Do you get this one? Yeah. Yeah. Okay. Okay. So let's say if you have to plot like that, don't be panic. I already give it to you. Okay. How you get that? Okay. So back to our slide. Okay, so now we want to visualize function. Okay, so previously we only have like sine x plus cosine x. Okay, z is equal to cosine x, cosine t. Okay, so the first step in displaying a function of two variables, z is equal to fxy. Okay, the value is to generate x and y matrix consisting of repeated rows and columns over the domain of the function. Okay, z is the output of your equation by x and y are the matrix, okay, repeated rows and columns. So that's why you see I put a pi, negative pi until pi, and the increment is pi over 500. It's the same value, and for y also the same. Okay, sometimes y is a bit different, but all the row and column is repeatedly. Okay, then use matrix to evaluate the graph function. Okay, and use mesh grid function to transform the domain specified by two vectors x and y into matrix s and y. Okay, and to illustrate the use of mesh grid, okay, you can use sine r or sine c function. Okay, you can use sine r or sine c function. Okay, to evaluate this function between negative a and a in both x and y. Okay, usually we use negative a and a in both in x and y. Okay, and MATLAB usually provides a number of techniques to enhance the information content of your graph. Okay, then use lighting and view adjustment to emphasize the shape of the graph function. Okay, we use the aspect, axis, view, and also cam lines. Okay, now I'm going to show to you, okay, how to visualize function of two variables. Okay, I'm going to copy the code and put it in Teams. Okay, okay. So this one is, okay. So here is, I create a mesh grid from negative 8 until 8. Okay, I create a mesh grid from negative 8 until 8. Okay, so here I put it as r is equal to square root of x squared plus y squared. This is my z, sorry, this is my equation. Okay, but I put here epsilon, which is to prevent it is divided by 0. If it's divided by 0, it will return into not a number. So I cannot produce a graph. Okay, then I put a z as sine r over r. Okay, sine r over r. Okay, then I plot using some function for x, y, z. Okay, the face color I use inter p. Okay, the face color I use inter p. I didn't put any edge color, so which means that there's no border. And face lighting I use go round. Okay, I label x, I label y, and I use d. Okay, so the aspect you comment first. You comment first. Okay, cam light also you comment. Okay, view also you comment it first. Okay, please comment the aspect. Axis type also you can comment it first. View, okay, all the fourth bottom line, can you comment it? Okay, then you run section. So you will get this. Okay, you will get this. Okay, so you see here, there's no edge color. Okay, there's no edge color. Okay, and the face lighting is gold. Okay, actually, there's more face lighting. Okay, you can also find it here. Many different names for face lighting. Okay, so this one is lighting name gold. Okay, this is a lighting used gold. Okay, this one is lighting when you didn't specify any. So it's like blue, 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 then turns to yellow. Okay, and you also can use flat. Okay, you can also use flat. Okay, and when we turn off the lighting, just off it. Okay, so you have three different methods: flat, full rod, or none. Okay, flat, full rod, or none. Okay, so here you use full rod. Okay, so this one is it like this. Okay, let's say you put the face lighting as flat. Okay, as flat. Okay, and edge color. This one is none. And put K, which is black color. Okay, so yeah, to be all black. Okay, because the edge is very the edge from one point to another one point is very narrow. Okay, and okay, now change back. Very okay. And how about the face color? Okay, you can find more here. The face color. Okay, so this is the face color. Flat is like this. Inter P is use interpolated coloring. So it will be like gradient like this. Okay, if you use RGB triplet, okay, it's according to what color that you put. Okay, and you have also texture matte and also night. Okay, so this is the RGB triplet color. So you have to specify it like this. Okay, but we're going to explore more after this, don't worry. Okay, so interpolation is like this. It's a gradient. Flat is like this. Okay, so now open back your uh, put back again each color 9, this lighting for X level. Okay, now you look at this D aspect 151. Okay, what is D aspect? So you see here, D aspect is like this. Okay, so it is, okay, 151 means 1. Okay, and this one is 5. The ratio is 5, and this one is 1. Okay, the ratio is 1. So which means that, of course, you can also just, okay, if you didn't put the D aspect, okay, by default, it will be like this, right? So, but by using the aspect, it's rotate for you. Okay, it's not, it's take it for you only from one value for X, which is X here. Okay, actually, it's only take X value, okay, 1, okay, Y value 5, and also Z value is 1. Okay, so that's why when you put the D aspect, it's only focused on few values of X and Y. Okay, it's only focused on few values of X and Y and also Z. Okay, okay, let's say we put this axis type. So axis type means, okay, okay, you put all of the axes, okay, according to the aspect, okay, according to the aspect. Okay, so this one is 5, 1, and also here is 1. Okay, and this view is like to the right side, right? Like this. Okay, So now I return view negative 15, 30. So we rotate it. Okay, instead of we use the cursor, we use the view command here. Okay, we use the view command here. Okay, from previously we look at it like this, right? Okay, so when I put the view negative 50, 30, so it will be like slightly tilt, a bit straight. Okay, we can also use cam light. Okay, we put the cam light on the left. It's actually um, like flashlight. Okay, when you take photo, you put a flashlight, right? So we put the flashlight on the left. So you see here, it looks a bit darker, but you can see the depth of the graph. Okay, you can see the depth of the graph. Okay, so you can play around with the code. Okay, let's say I don't want to do this, the aspect I don't want to do, but I just want to see if I put my cam light on the left. Okay, so when I put my cam light on the left, okay, so you see here, okay, somehow you see, yeah, it's more defined, maybe. Okay, so this is how you do a mesh grid for x and y, and z is according to the function of x and y. Okay, then you can use the aspect, cam light, axis, view, and so on. Okay. Okay, I have shown all of the functions that I put it here. Okay. Next is if you have data on surface. Before this, your data of x and y are in matrix, square matrix, right? Okay, what if it's non-uniform? It's like it's not according to the link space, not according to the proper interval. Okay, it's just a very, very spread data. Okay, so you can use mesh grid to create a grid of uniformly sampled data point, okay, at which to evaluate and graph a function. Okay, MATLAB then construct the surface plot by connecting neighboring matrix element to form a mesh of quadrilateral. Okay, to produce a surface plot from non-uniformly sampled data, we use grid data to interpolate the values at uniformly spaced point and then use mesh and serve in the usual way. Okay, if it is non-uniform, okay, we have a specific function that can make it uniform. Okay, then can make it uniform, which is use grid data. Okay, create mesh grid to create a uniform. But if let's say you have a non-uniform, it's all non-uniform, it's like scatter, use grid data. Okay, to interpolate it and make it uniform space point. Okay, uniform space point. Okay, so let's do it for non-uniform. I will copy my code and introduce. Okay, so this is a non-uniform, which is x and y. X and y, okay, is from a random number. Randy is random number. So it doesn't have a specific value. Okay, and z is depends on x squared plus y squared. Okay, then we use xlim, which is we create a linear lin space. So we do minimum value of x and maximum value of x and 1001, and y linear is lin space this. Okay, and after that, by using xlin and ylin, we create a mesh grid. Okay, then for our function Z, okay, we doing the interpolation of grid data from X, Y, Z, okay, and also X, X, Y, Y, okay, and we use cubic. Okay, so, okay, please comment this first. I want to show you how the non-uniform data is created. Okay, I want to show you how your non-uniform data is created. Okay, so you see here, X here is a random number. Okay, random number, 100 random number. So if you look at Y value, okay, is different from X. Y value also very different. It's non-uniform. Okay, it's non-uniform. And Z is X squared plus Y squared. Okay, so you see here, X squared plus Y squared. And now we create X lim. Okay, we create X lim. So it is between minimum and maximum. So they find what is the minimum value of X and what is maximum value of X. Then it create 1001 value between the values. So actually, if you see, minimum value of X is negative 7.8096 and the maximum value is 7.5. Okay, but for Y, the minimum value that they created is negative 7.9 and the maximum is 7.9. Okay, then they create 1001 value between it. Okay, then after that, we create a mesh grid of X linear and Y linear. Okay, we create a mesh grid. So you see here, the X value here. So this is the X value of minimum and maximum, but 1001 value. So we create a square data of 1001 value for X and create a data 1001 row, 1001 column for Y. Okay, so this is a square matrix of X and Y. Okay, then we open a figure. Okay, we use grid data. ZZ is a grid data. So grid data. Okay, if you run it, okay, you look at ZZ value. Okay, if you look at ZZ values, sorry. Okay, it's a grid data, X, Y, Z, and it's a cubic, but it's not. It's okay. Okay, then we use serve, okay, to interpolate our result. X is type, we put hold on. Okay, we put hold on. Okay, so here H color I put as none. Okay, then we interpolate X, Y. Okay, we use grid data, interpolate X, Y, Z. Okay, for X, Y, Y, the list space that we created before for 1001 value. Okay, so axis we put it as type, so which means that it's equal negative 5, 5 because it's the same value. Sorry, it has the same. Then we put snap. Okay, this one is okay when we do the interpolated data. Okay, so let's say okay we put hold on because we want to plot another one. Okay, we want to plot another one which is the marker. Okay, so here okay, Please uncomment the aspect first. Okay, so you see here, this is the marker, okay, for all the points of X, Y, and Z. Okay, this one, when what you saw is interpolation. Okay, it's the interpolation, but the marker here, the red dot here, is actually the actual data for value of Z, X, Y, and Z. Okay, the marker here is actually the real or actual data of non-uniform. Okay, and the rest of the color here is actually when you interpolated it. When you connect it, then you color the surface. But the real data is all this, the red marker. Okay, now we put the aspect. This one is we rotate the image a bit. Okay, so you rotate 117, so maybe to the front because we want to see inside. Okay, so this is how you do a surface graph, a non-uniform surface graph. Okay, we create a variable, we create a linspace, then use mesh grid and also grid data. Okay, we use a grid data. Okay, why we have a non-uniform data, but why we create the interpolation? Because we want to see the surface. That's why we do the interpolation. Okay, because we want to see the surface. Okay, any question? Okay, maybe it's too much information today. Okay, you come back, you have weekend, right? Okay, read again, try to run, then understand my slide. Okay. But no worries, so far from my previous, all students like this subject. Okay, yeah. No, all students like, especially if you come to the end of the course, you will see the moving graph. This one not moving, right? At the later chapter, you will see how the graph is moving. Yeah. Maybe that one until that part you will like it. Okay. Okay, so by default, MATLAB remove lines that are hidden from view in Matchplot, even though the faces of the plot are not color. Okay, you can also disable hidden line removal and allow the faces of a Matchplot to be transparent with the common hidden off. Okay, after this, we're going to use that hidden off. Okay, because we don't want to see the we want to see the line because MATLAB usually remove the line. Okay, that are hidden. And coloring mesh and surface plot, okay, I already show you. Okay, we can enhance the information content of surface plot by controlling the way MATLAB applies color to this plot. MATLAB can map particular data values to colors specified explicitly, or can map the entire range of data to a predefined range of color, which we call as color map. Okay, before this you see Bobrat, and actually an interpolation is according to the shape. Okay, but you can also explore around with a lot of color maps. Okay, color map is you use a RGB code, 3-column matrix whose length is equal to the number of color. Okay, I think I have shown you here. This is a RGB code color. Okay, and usually it specifies 3 values of the range 0 to 1. This value defines the RGB component, which is red, green, and blue component. Okay, color map function with no argument return the current figures color map. Okay, by default, the MATLAB can decide for you. But if you want to specify the color, this is like the RGB triplet. Okay, but some of my students, they prefer the hexadecimal color code. So it's up to you what you want to use. Okay, but if a short name is this, K, W for white, K is black, Y is yellow, no. Okay, so this is the RGB color component. Okay, so you don't have to memorize it. You don't have to memorize it because it will It's open book, right? So you know how to get the color. Okay, you know how to get the color. Okay, apart from this, that you like flat color of all this. Okay, before this we use Gorat, right? So you can create color maps with MATLAB array operation. Okay, so you can use color in MATLAB. Okay, apart from Gorat, you have HSV, hot, cool, summer, and gray. So each function has a optional parameter that specifies the number of rows in the resulting map. Okay, previously when you run all of this, is all in, okay, this type of color like Gora. Actually, you can specify it according to the hot, summer, all that color. Okay, if you do not specify the color map, MATLAB creates a color map same length as the current color map. What is current color map? Is Parula 64. You call it as Parula 64. Okay, and how to display the color bar? I have already shown you. Displays the current color map. Okay, together with your graph. Okay, we have done it before. Okay, done this right? Yeah, this one we have done it. Mm, and now we use view. Okay, view is to select your display, your graphical or graphical scene. Okay, we use viewing refers to process of displaying graphical scene from various directions, zooming in and out, changing the perspective and aspect ratio, flying by, and so on. Okay, usually viewing we use as 3D graph model, although you might want to adjust the aspect ratio of two views to achieve specific proportion or make graphic in a particular shape. Okay, so I know that by when you run this, okay, you can just switch around your cursor. Okay, you can just switch around your cursor. Okay, then you get the specific that you think. But somehow this is by default. Okay, you want your user, okay, to see. Okay, then by use view. Okay, so you want to use view. Okay, let's say previously maybe I put was here as 50, 90 maybe. So you want to specific. This bracket. Oh, the value is only between. Okay, I have to specify the value from 0 to 10 and all that. It's okay. Later on, we will do it more. Okay, because I didn't see the value of the X and Y. Okay, then somehow you want it to specific. Okay, you want it to be specific to look at the value at different angle. So which means that, okay, on this certain angle that you want to see, so you put negative 50, 30, and so on. Okay, now, before, okay, I give you a break until 10 a.m. Thank you. Okay, today I finish until this chapter. Practice question we do on next class because I want to give you early release so that you can focus on your quiz. Okay, I saw many have submitted, right? Many have submitted. Okay. Um, okay, make sure your graph, okay, is according to the question. Okay, don't forget to put the marker for your piecewise function. You know piecewise function? Put a marker at the end, the value, right? Okay, because it's stated, right? It's mathematically, it's not stated in the question, but it's stated because it's mathematics, right? So you need to put a marker of the value, right? Right, the marker for the piecewise function. Okay, and MATLAB enables you. Okay, next is we use the azimuth and elevation. Okay, we use the azimuth and elevation. Okay, so we want to set the viewpoint using azimuth and elevation. Okay, MATLAB enables you to control orientation of the graphic disabled in an Excel. Okay, you can specify the viewpoint, view target, orientation, and extent of the view display in a figure window. Okay, if you want to be more specific, okay, how the user look at your graph. Okay, so you have to specify by using all this. Okay, azimuth and elevation. Okay, these viewing characteristics are controlled by a set of graphic properties. You can specify values of all these properties directly, or you can use view command and rely on MATLAB automatic property selection to define a reasonable view. Okay, somehow when you just put on default, okay, without using any view function, okay, you cannot see some of the important features of your graph. So that's why we come up with azimuth and elevation. Okay, so the view command specifies the viewpoint by defining azimuth and elevation with respect to the axis origin. Okay, so the value that you put for azimuth and elevation is actually you have to it is begin with the axis origin. Azimuth is an angle, polar angle in the xy plane with positive angle indicating counterclockwise rotation of the viewpoint. So azimuth is in counterclockwise. It's not clockwise, counterclockwise. The angle above, positive angle or below the xy plane. So elevation is actually, if you have xy plane, so how elevate? So how your graph to be like elevate? Down or up? You understand how your graph, okay, your flat graph will be like this, right? So elevation is like how you control the angle to be like this or like this. Okay? Okay, that's elevation. Okay, so this is actually, what is it? Okay, so this is the center of the plot box. Elevation is where the angle between your axis line and how elevated it is. And azimuth is actually the angle, okay, of x and y. Okay, angle of x and y. Okay, so this is your viewpoint. Okay, this is your viewpoint. Okay, I'm going to copy some. Okay, this is by default. Okay, if you let MATLAB, okay, automatically set for you. Okay, so viewpoint is determined by whether the plot is 2D or 3D. For 2D plot, azimuth is 0, elevation is 90. So it is flat like this. Okay, for 2D plot, so for 3D plot, azimuth is usually negative 37.1. Elevation is 30. So it's a bit like this. So you can see it's in 3D. So this is like for 2D and 3D plot. Okay, so next is okay, then. Okay, the limitation of azimuth and elevation, when you specify azimuth and elevation, okay, it also has limitation. Okay, so it allows you to specify the actual position of viewpoint, just its direction, and the z-axis always pointing up. Okay, but if you do that, it does not allow you to zoom in and out on the scene or perform arbitrary rotation and translation. Okay, if you use azimuth and elevation, it will stick like that. You can zoom in and zoom out. Okay, and for axis, you can use x minimum, x maximum, y minimum, y maximum, z minimum, z maximum. Okay, places intervals of variation of the axis indicator value. Okay, so it's the same like 2D graph. You can specify x minimum, y minimum, y maximum, z minimum, z maximum. But of course, somehow you have a lot of value and you don't know. Okay, you don't know what value that you want to put. If 2D is easy, you just plus 0.5 minus 0.5 for minimum and maximum of x. Y minimum, you just plus 1 minus 1 like that. But in 3D, you have a lot of data. So instead of using minimum, maximum, we can also use the options of ij, or you can use x squared or x equal. Okay, that you use in two graph. So which means x squared means x, y, z will be the same value, equal also the same value. Sorry, square is not, sorry, it's like the same length, but equal means it's the same value. Okay, brighten P is adjust the lighting of the figure. Okay, it's in between interval -1 to 1, and the value P approach -1, the figure going to get dark. When it's approached +1, the figure is illuminated. Okay, brighter P is actually another alternative for phase alpha function. Okay, or phase alpha function. Usually, I use phase alpha, but let's say if you have a more, okay, if you want to explore more, you can also use brighten P. Okay, I give you a code for this. View specified with azimuth and elevation, I put in Teams. Okay, so here is like a very this one is okay when you use view 180, okay, and okay elevation 0, okay 180. So it means like we rotate it 180 degrees. Okay, so you run it, you will get like this. Okay, so let's say if you disable the view before this, you look at the graph like this. Okay, but when you elevate it 180 degrees by using the view command, you will say it black. You will see it black like this uh on X, yeah, on X, on X axis. Okay, so this is how you use view. Okay, let's say now I want to use a view here. Okay, 180, maybe here I put 90. Okay, so you see here, it is here, elevation is 90 degree, okay, but azimuth is 190. Okay, let's say here I put maybe here 45, and elevation is 90. Okay, so you see here, okay, elevation will lift up by 90 degrees. now to see what it will be. Okay, this is when you elevate 90 degrees, like how I did. Oh, but if you use the MATLAB, the previous MATLAB version, actually you cannot, when you use view, you cannot rotate it anymore. But now it's version 2024, yes, still rotate it, although you specify your azimuth and elevation. For this, we cannot do it. Okay, so this is how it is. Okay, next is, okay, we want to see it in 3D. Okay, comment this view and comment the title and comment the bottom two line. Okay, this one is I want to show, before this 180 is 2D, right? Okay, this one is in 2D, but next is I want to in 3D. Okay, so here you see it's negative 37.5, so which means that it written in clockwise. Okay, it's clockwise. Is clockwise. So this one is when you return okay, before this you look at this, but this one is, it looks like this. Okay, so this is how you play around with your graph. Okay, any question? Any question? Oh, are you doing quiz one? You're doing my quiz one. Okay. Okay, so if you don't have any question, make sure you do quiz one. Next week will be quiz two. Okay, quiz two we cover chapter 3 and 4 next week. Okay. Again, it's the same thing, multiple choice question. We cannot do in class. Okay, we cannot do in class because of the limitation of the PC. So many of the PC cannot be used, right? Cannot, right? Many of the PC cannot be used. Hence, we have to do it online for quiz 1 and quiz 2. Let's see how quiz 3 is. But for quiz 1 and 2, the same format. And also, okay, some of the students ask me, I want to do multiple attempts on multiple choice question. You can, but the last score will be the last attempt, not the highest score. No, the last attempt. That will be the last score, your score. Understand? It's only 5 questions. For quiz 2 also, I think is I haven't seen the question yet, but only also have 5 questions. But for quiz 2, I did the plot. Yeah, I did the question for plotting. Okay, any question? No. Okay, so open your, what is it? Power Apps.